In level 2, you will be identifying characteristics of graphs. You'll be looking for local maxima and local minima, which are high points and low points. When a function is negative, when it's positive, when it's above or below the axis. When it equals a certain value, you'll be finding x and y intercepts, and when a function is either increasing or decreasing. And a lot of this can be done with a calculator, and you'll be expected to know how to do it with a calculator. So first, just a little bit of review of domain and range. Domain is the lowest x value to the highest x value. So if I look on the x-axis, this function is defined starting at -9 on the x-axis, and it is defined as I head in this direction to infinity. Because of this arrow, it goes to the right forever. So the domain for this function, I'm going to use a bracket at -9 because -9 is a filled in dot, that point is included, and then I do comma infinity. Infinities always have parentheses. Okay, next I'm going to find the range. The range is the lowest y value to the highest y value. Oops, erase that. So the lowest y value, or the lowest point on this graph, is right here, and that y value would be -3. And then I do have a high point right here, but because of this arrow, the function is going up forever. So the range for this function would be -3, again a bracket because of this filled in circle, to infinity. Okay, next we are looking at the interval where the graph is increasing. The graph is increasing whenever it's going up from left to right, so that happens right here, and right here. So I need to list all of those intervals. For increasing and decreasing, we always use parentheses because technically a graph doesn't increase or decrease at a certain point. When we talk about intervals, we're looking on the x-axis. So for this first part right here, the interval would be -9 to -6. And in interval notation, we get -9 to -6. The next place where it is increasing was from -4 to -3, just this part right here. So again, parentheses, -4 to -3, and it's increasing from 2 to, not 5, infinity. So the last part would be 2 to infinity. When is it decreasing? So this is pretty similar. When it's going down from left to right, and it goes down right here and right here. So the intervals where it's decreasing would be -3 to -1 and 1 right here, this part, so that would just be from 1 to 2. Okay, and then for the next part, part E, for what interval is f of x less than 0? This is asking when is the graph negative, or when is it below the axis, and below the x-axis, that is. It is negative right here. This is the only part where the graph is below the x-axis. And I'm going to use a parenthesis in this case because I don't have the or equals line. So at 1, the graph actually equals 0. So I have to use a parenthesis because that point is not included because the graph is technically not negative at 1. So I use a parenthesis from 1 and then to 3, and again at 3 I use a parenthesis because at 3 it actually equals 0. In between those, it's below, and the graph is, or the function's negative. But we use parentheses because those points aren't included. Okay, and for the next one, the minimum value of f of x. Whenever it asks for a minimum value, that is going to be a y value. Okay, so the minimum y value at this point, the lowest point on the graph, is -3. So the minimum value of the function is -3. And then the local maximums, a local max is a point where you have a high point on the graph, and that would be this point, a point that's higher than any other point around it. So it has one local max, and that would be the point -3, 9. Now, note that this is not the highest point on the graph. Because of this arrow, this graph does go up forever, but this is the highest point around it. So whenever it's like the top of a mountain, that would be a local max. And then a local min is also a point, and that's going to be like the bottom of a valley. So a local min in this graph would be this point right here, where you have a point that's lower than any other point around it. And that would be 2, -3. The other part of level 2 is going to be using a graphing calculator to find all the same information from a graph. So what you're going to do is, eventually we will know how to do something like this by hand, but for now you're going to plug this function into your calculator. So you're going to go to y equals, and you're going to plug it into y1, and you're going to hit graph, and you're going to get a picture of the graph, and you're going to draw the sketch, which should look something like this. And then using your graphing calculator, you're going to find the x-intercepts, y-intercepts, local max, local min. You might also be asked to find when it's increasing, decreasing, when it's greater than 0, same things we just answered in our last example. Now, I will go through this example again in class and show you specifically how to do it on the graphing calculator, but you're going to find the x-intercepts, which are these points right here, and they are located at -3, 0, -2, 0, 0, 0, and 1, 0. So those are the places the graph touched the x-axis. The y-intercept happens to also be an x-intercept. This point right here is where it touches the y-axis and the x-axis. So the y-intercept is 0, 0. The local max and local min, any local maximum is a high point like the top of a mountain. So this would be a local max right here. This would be another local max, and this would be a local min. Using the graphing calculator, I found that this first local max is the point -2.58, 2.25. So -2.58, 2.25. And this next local max over here would be the point 0.581, 2.25. So that would be the other local max. 0.581, 2.25. And then the local min is the point -1, -4. And I will show you, if you don't remember, how to find all those things in the graphing calculator in class.